minus rotation from the element shown. Okay, so now we are going to do that now. So from here, immediately, like what I told you, once you have these values, the most logical, or the first thing to immediately calculate is the center of the circle. So center of the circle is our stress average. So the stress average will be equal to minus 560 plus by 250 divided by 2. So this will give us a value of minus 560 plus by 250 divided by 2. So our stress average is at minus 155 megapascal. Okay, so now we can sketch. So if we look at our limits, we have a compression of minus 560 and a tensile of 250. Okay, and then our shear stress is quite high. Okay, our shear stress is at 400. So now I'm going to sketch. So this is our normal stress. So let's see if we have enough space. So minus 800 minus 700, 600, 500, 400, 3, 2, 1, 0, 100, 200, 300, 400, 500. Okay, so this is our normal stress. Then we are going to draw our scale for our shear stress. So the scale for our shear stress, we have shear rotating clockwise at the top. So again, the scale has to be the same: 100, 200, 3, 4, 500, and we have 600. Okay. And then we have minus 1, 2, 3, 4, 5, and 6, and element rotating clockwise. Okay, so we're going to find our original element position of point X and point Y first. So we have a negative 560. Okay, so negative 560 is going to be somewhere about here. Okay, so 560. And then we have a tensile. So this is our stress X. Okay, so this is our stress X. And then we have a 250. Right, so we have our 250 over here. So we have our 250, which correspond to our stress Y. And then the shear, we have what? On our shear, we have 400. So we put in, that's weird. Why I put 450 over there? 400. Okay, so we sketch our 400 shear line. Hey, wrong color. So that's our 400. And then we have another 400 down here. And then we put our finger on the center, right? At point X, it will rotate the 400 over here, will rotate the element in a clockwise orientation, right? So clockwise will be on the top. So this will be our point X. Okay. And then the 250 is going to be anti-clockwise rotation. This will be our point Y. Okay. So from here, we can immediately draw a straight line. So this is our straight line. I'm trying to be accurate over here. And then where it intersects the shear stress, which is equal to 0. Okay, so it's over here. There's our center of circle. So our center of circle, we immediately label this as point O. Okay, we can immediately label this at point O. And then from here, we can also determine our tau max. Okay, so we can immediately calculate our radius of the circle. Okay, which is tau max. So tau max will be equal to 400 squared or minus 400 squared, but does not matter if 400 or minus 400. Okay, plus. Okay, so why 400 is because we know the distance from here to here, right? We know that this is equal to what? 400, right? And then the next one we have to find is we have to find this distance over here, right? So the distance over there is going to be what? It's going to be the minus by 560, and then minus by minus 155, right? So this will be equal to minus 560, 155. So you have 405 or minus 405. So immediately you have your minus 405 squared. So your tau max is equal to 400 squared plus by 405 squared, and then square root the whole thing, 569.232 megapascal. Okay. So from here we can immediately calculate our stress 1 and 2 principal stresses. So it's equal to minus 155 plus by 569.232. Okay. So minus 155 plus 569.232. So one principal stress value is 414.232 megapascal. And the other one, plus minus, is 724 minus 724.232. Okay. So we know that tau max is 569. Okay, so I'm going to sketch our tau max value, right? So tau max is at 569. Okay. So I'm trying to. So this is our. Nope, sorry. 550. Okay, so 569 is somewhere. So 575. So this is somewhere 569. And then we have to go to the next 569. So 550, 575, 569, somewhere around here. And then our principal stress value is at 414 and 724. Okay, so 724. Okay, so 724 is somewhere around here. And then the other one is 414. Okay, so 414. Okay, so that is the other principal stress. Okay, so 414 is somewhere. I'm going to eyeball this. So this is 425, 414 is about here. Okay. So from here we can sketch our Mohr circle, I hope. So we can sketch our Mohr circle. Yeah. Not the most precise, but close enough. Okay. Let me see, can I? Yeah. Okay. So this is for our XY plane. Okay. So we were told, or we were given, that over here we have to rotate in a anti-clockwise direction. Okay. Y60. Y60 means from point Y. Okay. Not from the horizontal axis. Yeah. It's from point Y. Okay. So Y60. So in anti-clockwise, so we have to rotate 120 degrees. Okay. So I'm going to use my protractor and I'm going to rotate this by 120 degrees. Okay. So this is where 120 degrees is. Hold on, let me. Okay. So this is from point X, from point Y, and the rotation, right? The rotation in over here. Okay. Over here, it will rotate by 120 degrees. Okay. So now the thing is we now have to identify, or we have to determine this acute angle over here. Okay, and I'm going to call it our angle beta. Okay, so before we determine angle beta, we can also determine our 2 theta p, right? So from here, tangent 2 theta p will be equal to 400 divided by 405. So our 2 theta p will be equal to 400 divided by 405, and then inverse tangent. I'm in radians. That's why I have to be in degrees. Okay, so 400 divided by 405 Inverse tangent, I have 44.6 degrees. Okay, 44.6 degrees anti-clockwise. So the beta angle